Well, hello again. Welcome back. It's now time to have a look at Pythagoras' theorem. I'm going to give you a quick little bit of background, as you can see on the screen here, where it came from. It's all about squares. It's got the equation right down the bottom here. And more importantly, I'm going to show you how to solve problems. It really is quite quick and easy. So let's have a look over here first. Pythagoras' theorem, as I said, the theorem says a squared plus b squared equals c squared. Now, Pythagoras was an ancient Greek guy who, somewhere along the line, figured out that if he had a square and he put it at 90 degrees to that square, if he added the size of that square, the area of that square, and he put a third square there, that squared plus that square equals that squared. Hence the equation. That's all the background I'm going to give you. All right, and more details about the actual theorem, though. Here we go. First up, it only deals with right-angled triangles. And it only deals with the sides of the triangles. Now, trigonometry deals with angles. Pythagoras deals with the sides. Okay, there are 5 steps for both Pythagoras and trigonometry, but we're just dealing with Pythagoras for now. So let's have a look at these steps. First step, draw your triangle. Draw a right angle triangle. Okay, let's do that. There's a right angle triangle. Is it a right angle triangle yet? Not yet. We're missing the right angle, so we need to put the right angle in here. Second step, label the hypotenuse first. Now, that's a new word. Hypotenuse is just the name for the longest side of the triangle. Okay, see that one there? That's the longest side. The other way to pick it, it is always going to be opposite the right angle down the bottom corner here. Okay, so we'll label that one, and we always denote the longer side, the hypotenuse, with the letter C. Okay, so here we go, hypotenuse equals C. You don't need to write hypotenuse equals C, you can just label it C. I'm just putting the word there for now so you can see it. Now, the A and the B, the other two sides, doesn't actually matter. That can be A, that can be B, or that can be B and that can be A. Doesn't actually matter. All right, third one. Always, please, most important, write Pythagoras' theorem out. A squared plus B squared equals C squared. When you're doing your working, that's always the first thing you should do. Please don't leave it out. It just stops so many silly errors. Fourth thing we need to do, substitute what we know. Well, we can't do that just yet because we've only got A's and B's. We haven't got numbers there. You will get problems with numbers, which you're going to substitute in place of A and B, or maybe C. You will be doing one later. And finally, the fifth step is rearrange the equation and solve it. Straightforward, 5 steps. Draw, label, write the theorem, substitute, solve. Awesome. Okay, let's have a look at the problem. Now, I've put up here, you can see I've put the steps up here just to remind us, and we're going to go through this one. Find the length of the unknown side in the following triangle. Well, first up is draw your triangle marking the right angle. So we've drawn it, we've got the right angle there, we can skip that step. Not skip it, we've done it. Label the hypotenuse C first. So which one's a hypotenuse? There it is, opposite there. And then A and B. Now again, doesn't matter which one's A and which one's B, just randomly A and B there. Third step, write Pythagoras' theorem. So we'll write it over here, A squared plus B squared equals C squared. You're about to see why it's important. Substitute what you know. So we know that A equals 5, so let's bring the 5 over here and put the squared up. Plus, we know B equals 7. Let's bring it over. And that's 7 squared. And we're going to work out what C squared is. Next step, rearrange if necessary and solve. So no rearranging yet, but we can work out what 5 squared is. 5 squared is, of course, 25. Then we're going to add 7 squared, which is 49. And that equals C squared. Now, I'm just going to stop right here before we do any more. Have a look at this. See what's lining up right here? Are all the equal signs. please, when you're laying your work out, line up your equal signs straight down like that. Don't go zigzagging all over the place. Just line them up. It makes it much easier for whoever's looking at it, whoever's marking it, to see what's going on, what's changed, what's shifted, all right, from side to side. All right, back to it. 25 plus 49 is 74, which still equals c squared. Now, common mistake. People stop there and go, yeah, c squared is 74. That means that length is 74. It's not. This is c squared. We don't want c squared. We want c, which means we have to get rid of this squared here. How do we get rid of a squared? Well, what's the opposite of plus? Is minus. What's the opposite of times? Is divide. What's the opposite of a square? Is a square root. So we're going to do the square root of 74. Now we've got the c by itself. You can type that in the calculator and you will get c is approximately equal to 8.6. Quick check time to see if you've done it right. 8.6, does that sort of fit? It's the longer side. That's good. It's longer than the other two, but it fits much better than 74, sorry. 74 would be way too long, wouldn't it? So it makes sense that it fits. All right, so that's finding the hypotenuse. Next example we're going to look at is we know the hypotenuse, we know one of the shorter sides, so we're going to find the other shorter side. This one involves a bit of rearranging. So draw your triangle, mark the right angle. There's the right angle, there's our triangle. Label the hypotenuse first. So here's our label on the hypotenuse, C. A and B, doesn't matter. Let's put an A over here and a B up there. Third step, write Pythagoras Theorem. So A squared plus B squared equals C squared. And substitute what we know. Well, do we know the A? No, we don't. So all we're going to do here is we're going to keep writing A squared. We know the B, which is 2, so it's going to be plus 2 squared. And we know the C over here, which is, of course, 9, so equals 9 squared. We can simplify this a bit. We know what 2 squared is, so we'll keep the A squared for now, plus 4, and we know the 9 squared is 81. Got it? Okay, here's the rearranging part. We need to get A by itself, don't we? So we have to work backwards. So we have to get rid of this plus 4. How do you get rid of plus 4? Remember the opposite? So we have to take away 4. So take away 4 here, and we have to do it on the other side too. The 4 minus 4 disappears, so you're left with just the A squared. Line up the equal sign. 81 minus 4 is 77. Now we have to get rid of that pesky squared again. That is the square root, so it becomes A equals the square root of 77, which is approximately 8.77. Let's just quickly check back here. 8.77 is less than the hypotenuse, less than the longer side. So it fits in there. Makes sense, doesn't it? All right, now the dreaded worded problem. All righty, here we go. Josh has an extension ladder that is 9.8 meters long. He needs to clean the windows on the outside of a building. The lower part of these windows is 9.8 meters from the base of the building, and they are 1.2 meters tall. Unfortunately, the closest Josh can place his ladder to the base of the building is 3 meters. So that would be, there's Josh cleaning the windows, isn't he lucky? So that would be there to there would be 3 meters. There to there would be the 9.8 meters up. And the window itself would be 1.2 meters tall. Because there's bushes. Oh, he must have trimmed the bushes in that picture, preventing him from putting it any closer. And Josh himself is 1.7 meters tall. So we need to make a triangle out of this picture, don't we? So let's see what we've got. We'll put a building there. Just draw it for now. Just draw what you've got. On top of the building, we have a window. So there's a window. We have the ground. So we'll put the ground down here. And of course, Josh is going to be standing on a ladder. Well, there's our triangle. What do we know? We know the building is 9.8 meters tall. Now that goes up to there. We know the ladder doesn't go all the way up to the top, because if Josh's ladder is 9.8 meters tall as well. If you have two 9.8 meter tall things, as soon as you lean one over, it's not going to reach up the top, is it? So you see the ladder is a little bit below here. We know the window, that is 1.2 meters to the top up here. We know his ladder is 9.8 meters long. And we know the closest he can get the base of the ladder to the wall, to the building, is 3 meters. All right, now this is getting a bit of a messy triangle. So let's pull the triangle out. So here's a triangle, stops there. Okay, let's pull it out there and we'll put the measurements that we know on it. We have the 9.8, which comes over here, and the 3 meters there. And the first question says we need to calculate the height the ladder reaches up the building, which is from there to there. So from here, you see it's not 9.8. So we need to work out exactly what it is. All right, first step, draw your triangle marking the right angle. There's the right angle. Got it in there. I snuck it in there, sorry. Label the hypotenuse first. There's the hypotenuse, which is your C, and then the A and the B, of course. Again, doesn't matter. Next step, write Pythagoras' theorem. Well, let's bring the question out. We're going to work this out. So we'll do part A first. I should have done that first, actually. Okay, now we'll write Pythagoras' theorem. A squared plus B squared equals C squared. Do we know A? Nope, that's A squared. Do we know B? B is 3, so plus 3 squared equals the 9.8 meters squared. Good so far? All right, let's simplify that a bit. We have A squared, 3 squared is 9, and 9.8 squared is, let me guess, 96.04. There we go, 96.04. So you get good if you keep practicing. All right, what do we have to get rid of? We have to get rid of the plus 9 onto the other side because we want the A by itself. So opposite of plus 9 is, again, negative 9 from both sides. So we're left with the A squared here. And 96.04 minus 9 is, of course, 87.04. Now we get rid of the squared. Squared comes over the other side as a square root. So it's the square root of 87.04. And grab your calculators because this is a little bit ahead of me too. Oh, sorry, I'm not so good with the square roots, but hang on. That is about 9.33 meters if you round it. Okay. What does that mean? Well, that means that the ladder reaches 9.33 meters up the wall. So that length there is 9.33. So up to here would be 9.33. First part of the question answered. Now let's do the second part. Explain whether Josh will be able to reach the top of the windows to clean them. How do we do that? Well, we know the wall is 9.8. We know that the window is 1.2, so add them together. Josh has to be able to reach 11 meters up if he's standing on the top of the ladder. Now, how tall is Josh? Well, Josh's ladder was 9.33 meters. We worked that out in part 1, and he's 1.7 meters tall. So that means he can reach up to 11.03 meters. 11.03 is bigger than 11 meters, isn't it? So that means that Josh will be able to reach the top of the window. He's got 3 centimeters to spare. Done. So he can clean it. Lucky Josh. Glad he's not any shorter though. All right. Now, hopefully that's enough for you to get going. Just please remember these 5 steps just here next to me. Draw your triangle marking the right angle. Label the hypotenuse first, then do the A and B. Then write Pythagoras' theorem, substitute what you know, and then rearrange and solve. Straightforward 5 steps. All right, go for it. Good luck.